Welcome to JAMB Physics revision class with Chris. This is a series videos where I'll be solving 40 to 50 type of questions you're going to see in your JAMB examination. So if you are going to write the upcoming JAMB is about, as the time of me recording this video, JAMB is about 7 days to go here. So my goal in this video, set of video, is to solve those topics that you will likely see in JAMB examination. And this is going to be the second video, right? In this second video here, I want to focus on two main important topics in JAMB Physics syllabus. One is what is machine, two is what is temperature. Now the first video will focus on electrical energy and linear momentum. If you know that you have not checked out the first video or you have not watched the first video, please, the link will be at the description below so you can go check out that video by the time you finish watching this video. Do you understand? And the good thing here about this video here is that for every topic I'm going to treat here, like I'm treating what machine and what temperature here. I'll show you that by the time you finish watching this video here, you have covered every single thing into what understand and to be able to solve any question when you see under what machine and what temperature. So you want to stick to the end of this video here. If this video is helpful, please give it a like and leave your thought at the comment section if this video is helpful. Do you understand? And if you're not subscribed to the channel, please kindly hit the subscribe button so that whenever I upload a new set of videos, like this kind of videos coming up, you'll be notified that a new set of video will be uploaded. Do you understand? So you want to make sure you have your pen, your notebook, and also your calculator, right? So I can follow through this video. Because of me teaching here, I will change the values, right? I will change the values so that you could use that value to solve your own question, and I will advise you to leave your answer at the comment section to check if you are correct or not. Do you understand? So now let's get into it here. So we are starting with machine. So we have these two questions here on machine, but before I start some question here, you need to understand what machine, right? So now the thing to understand machine here, the first terms you need to understand in machine is called mechanical advantage. Mechanical advantage, which is A. Mechanical advantage. Now, what is mechanical advantage? Mechanical advantage is load over effort. Load over effort. That is the first thing to know here. And is L over E. Is okay. So when you're calculating mechanical advantage when it comes to machine, is load over effort, right? And there are forces, and forces measured in Newton. As we move on, you go to understand it. Now the second thing to understand is called velocity ratio. Velocity ratio. Velocity ratio is very easy. Distance moved by effort over distance moved by load. So you have distance moved by effort over distance moved by load. Now and is what? So here is capital letter E, not small letter E. Load is capital letter L. Effort is capital letter E, right? Now, distance moved by effort is signified by small letter E. So in machine, small letter E is distance moved by effort over distance moved by load is small letter L. Just so there are the two first formula you need to know when it comes to machine. Another thing to understand in machine, please pay attention, is called efficiency of machine. How efficient the machine is, please pay attention. So the efficiency, which is the E, is equal to what? Now, work output over work input. Machine, now efficiency have different formula. So, but the first one now, let me give the first one. The first one is is mechanical advantage over velocity ratio times 100 over 1. Is okay. So mechanical advantage and velocity ratio are related with with efficiency. MA over VR times 100 over 1. But this is not the only formula you need when calculating the efficiency of a machine. There's another formula here which is efficiency equals work output over work input times 100 over 1. Now, what is work output? Like, what is work input? Now remember, a machine, what do you use machine for? A machine is something that will make our work easier for us. Do you understand? So we have different type of machine which I'm going to we are going to solve different problems when it comes to different type of machines. So please pay attention here. So now you need you need an effort to overcome what a load. So you need what for you to be able to what have an efficient machine here, or if the machine is really what efficient here, the effort you put in must be greater than what than the load. Do you understand? And we have different type of machine which are going to look at here, right? So the work output is what is the work you use, like is like the output is what is the load, because we have two things here: effort and load. Do you understand? So the output is what is load you are overcoming. The input is what is effort you are what you are. So here we have output, input. Now this input is what is like what loads. This output is like what is like the effort. Do you understand? So yeah, work done by the loads. So the work output is related to what load. The work input is what related to what effort. So now look at something here. Work output is equals to what? Load times distance move by what? Load. Is okay. Work output equals to load times distance move by what? By load. Very important here. Then work input equals to what? Effort times distance move by what? By effort. Do you understand? So work output is what? Is load times what? Distance move by what? Load. The work input is what? Effort times distance move by what? By effort. By effort. Do you understand? So now load must be what? In Newton. Effort must be what? In Newton. So these are what the various formulas you need to solve problem when it comes to what? Of machine. Do you understand? When it comes to what? Machine. There will also have a different type of machine. We have different type of machine which we are going to look at. So now with this, now let's start solving some key problem. Now let's start solving this question here. Now let's start solving this problem here. So now let's look at what the first question, very important here. The first and second question, they are related. So please pay close attention here. Let's look at what the first question here is. That a machine has an efficiency of what? 35%. So let us write our solution. The efficiency of the machine is 75%. Is what? 75%. The work done when the machine is used to raise a load. Now the load, what is the load? The load is what? 50 what kg, right? Through a vertical distance. So now you have distance moved by the load. Distance moved by load, which is what? Is the small letter L equals to what? 6 what meter. Just this that they're asking, what is the work done? What is the work done when the machine is used to raise a load of 50 kg through a vertical distance of 60 what meter? Right? Now this work done here is called work input. So they're asking here, what is the work input used to raise that load, to overcome that load? Do you understand? So they're asking work input. This is what they're asking you to what to calculate here. Do you understand? Now the first thing you want to do here is to calculate, is to convert this guy to what? To Newton. So when the mass is being given to you, you are not using the mass like that, because the load is just like the force output, force input. Force output is what is the load you overcome. Force input is what is the effort you put in. Do you understand? So whenever this is being given to you, in some question, the load will be giving you what in Newton. In some question to be giving you what in kg. If the question, the load is giving you what in Newton, fine. But here is giving you what in kg. And you cannot use like this. You have to go convert this guy, this load now, to what? To force. And how do you convert to force? Remember force equals to what? The M, right? The mass times acceleration due to what? Gravity. So you convert it to what? You convert it to what? You convert it to what? To force by multiply by what? 10. So if you multiply this by 10, my load now will not become 500 what Newton. So yeah, you convert what this 50 kg to what? To Newton. So that become what? 500 what Newton. Hope you understand. So they're asking here work input. So these are all the parameters given to us. So yeah, remember the efficiency of a machine is equal to what? Work output by what? Work input times what? 100 over 1, right? So now this is the work input that what you are looking for, right? So let's calculate what the work output first. Now, what is work output? Work output is equals to what? Load times distance moved by what? By load. This that, which is going to be what? 500 Newton times what? 6 is okay. So if you multiply it here, 500 times 6, 500 times 6, here we have what? 3,000 what? Newton, right? So my work input here is now what? 3,000 what? Newton here. Hope you understand. So now let's make work input the subject of formula. If you want to make work input the subject of formula here, right? So here we are going to, you should do your calculation here, like do your cross multiply and make work input the subject formula here. What are you going to get? It's going to be work. Remember, there's no space here again, so I'm coming here. So what will happen here? So work, what is going to do? Work inputs, which is the work done, equals to what? The work output times 100 over what? The efficiency. This is that. So you have what? The work output. The work output is what? Is 3,000 times my 100 over what? Over what? 75. It's okay. So 3,000 times 100 divided by what? 75. Here we have 4,000. Say what? 4,000 what? Joules. 4,000 what? 4,000 what? Joules. So the work done is 4,000 joules. Work input. So you can start say work done equals what? 4,000 what? Joules. The answer is what? Is B. The answer is what? Is A. The answer is what? Is A. So is what? Is 4,000 what? Joules. That is the what? Is the answer here. Hope you understand. Now let me change this stuff here. Let me change here to what? Now let us say here is what? Is 80%, right? Now let us say here is what? Is let us say 90 kg, and here we have what? 12 what meter here. Go ahead and solve this one for me, right? I just changed value here. Remember, you should see this video as your revision. Do you understand? So anything you are doing, you just imagine that you are not reading machine again. This is the only video you need to read. This is the only video you need to watch for what machine. So I've saw the first one, pause video and do this solve this one for me. Leave your answer at the comment section, right? So let's solve the second question here. Very important. Let's solve the second question. Please pay close attention. What is the second question here? 500 joules of work is required by a machine to raise a load of 250 Newton through a vertical distance of what? 1.6 meter. What is the efficiency of the machine? What is the efficiency of the machine? So remember, efficiency of the machine is equal to what? Work output over work input times 100 over 1, right? Now, there's 500 joules of work is required by a machine to raise. So the work you put in is what work input here. Just so this is the work you put in to raise a load. Hope you understand. So yeah, the question I've already given you what? Work input. So work input is equal to what? 500 what? Joules, right? Now, if you look at the question very well, they gave you what? The loads and distance moved by the load here, right? So remember, work output. Now, what is work output? Work output is what? Load times distance moved by load. So what I will just do here is that work work output is equal to what? Now, is what? The load itself times distance moved by load. Now, the load is what? Is 250. So we have 250 Newton times. What is distance? Distance is 1.6 watts meter. So here we have, so let's do this together. Here we have 250 times 1.6. Here we have 400. Here we have what? 400 watts Newton. 400 watts Newton. So now I now know what my work inputs, my work outputs. I know what my work inputs. So I'll just input what my parameters here. So the efficiency of the machine is what? My work output is what? Is 400 Newton over. My work input is what? 500 watts Newton times what? 100 over what? 1. So you have 400 times 100, right? Divided by what? 500. Here we have what? 80. So here we have 80 what percent, right? So the option is what? Is A. So you can see how easy it is to solve problem here. You can see how easy it is, right? So the option is what? Is A. Now let us change this value here. Let's change this value here. Let us say here we have what? 650 joules. And here, now let us say here is what? Is 380 Newton. And let us say here we have 1.8 meter. Now, one of the worst things you can do to yourself here is this: is to tell yourself that I will solve this question later. You are just fooling yourself. Just now, like when I say you don't have any other time again to come back to machine. Just so as I watch this video here, just see that okay, this is the only video I need to watch on machine and what temperature change. And after this year, I've understood every single thing. That is what you do. And the only way you can do that here is not for you watching me solving question. Now, when I'm solving question, you can easily say you understand. But the real point is when you're learning is when you are solving question on your own. So you find that when you actually understand something more or better is when you are doing something on your own. So now this is the reason why I want this class to be interactive. Now, I have changed the value of this guy here. I have changed the value of this guy here. You have to pause this video. Don't continue. You have to pause this video and solve this question. Now, after you solve the question, what you want to do is to drop your answer at the comment section. Let's interact at the comment section. So we are done with the first set of questions. Let me go to the next set of questions. Let's look at what these two set of questions are really going to be type of what machine. If you look at this question, question 3 and question 4, you see that here we have block and tackle system of pulley, and here we have what wheel and axle. So now these are type of questions you like to see in what in your JAMB examination. So please pay close attention here. We are still going to solve two other questions that involve what or that type of what machine, right? So like what I said, my goal in this video here is to what finish everything about what machine. So by the time you send a question on that machine, you'll be able to what to solve it, right? Now before you continue here, now please let me just say something here. You know that this video is helping you. They kindly support this YouTube channel, right? So I don't depend on YouTube monetization. I only get my money through my online class and through support, right? And I've told myself that between now and when JAMB will start, I'll be producing like 2 videos every single day. And the cost of producing video and uploading video is much, especially with data, right? So in my last class, when I talk about organic chemistry, a large majority of you are supported, right? Some send 2,000, some send 1,000, some send 4,000, and I really want to appreciate you guys. You guys are the reason why I'm producing this video. So now I'm just here to be of help to you, but it can also be of help to me to not only like and subscribing by donating any amount you can donate. That shows that you are worth supporting, right? So for donation, you can donate from anything in your mind. It's a free will. Just like the way I'm doing free will here to try to help you in your JAMB examination for math, chemistry, and physics. It's also a free will and support that. Thanks for producing this video like this, and I want to support. Do you understand? Any amount at all. The account number will be on the screen. You can send any amount at all. 500, 1,000, 2,000, any amount you want to send, and I will really want to appreciate. Now, once you send money here, please send me a message on WhatsApp because I will have a free gift for you. Do you understand? And I really appreciate it very well. Right? So you can donate any amount, right? I'm just begging, right? I don't want to depend on YouTube. So I just want you guys to support what I'm doing here, especially if you know that you are getting value from this video. So now let's look at the third question here. A block and tackle system make up a 5 pulley is used to raise a load of 700 Newton with an effort of 200 Newton. What is the efficiency of the machine? So they're asking what is the efficiency of the machine. Now, when it comes to a pulley system, right? A pulley system here. Now, what separates the different type of machine is what? Velocity watt ratio. The mechanical advantage remain the same. The formula for efficiency remain the same. So what separates one type of machine from another is the velocity watt ratio. So every type of machine have their own different velocity watt ratio in which they used to calculate. They have a different way they used to calculate their velocity watt ratio, right? And for a block and tackle system, right, which is pulley here, the numbers of pulley is equal to the velocity watt ratio. Just and the numbers of pulley equals to what? The velocity watt ratio. So the velocity ratio here is what? They say what? 5 pulleys. So it's going to be what? 5. Just as easy as that. The velocity ratio is what? It's 5 because how many pulleys do you have here? 5. At times you will not be giving the velocity ratio. You only give out the diagram. Now when the diagram is given to you, just count the numbers of pulley. So it can be 6, so it can be 5, so it can be 4, depending on the type of pulley. Just so yeah, they didn't give us a diagram. They only gave us what that the numbers of pulley is what is 5. So my velocity ratio here is what is 5, right? If you check it very well, they gave us loads. My load is what is 700 Newton. My effort is what is 200 Newton. Now what they say, calculate the efficiency of the machine, right? And I'll give you what the formulas for to solve what efficiency of the machine. The efficiency of a machine is equal to what? The mechanical advantage over what? Velocity watt ratio times 100 over what 1, right? Now, my velocity ratio have already been given to us here. Velocity ratio have already been given to us, right? Velocity ratio have already been given to us. So the next one to calculate now is what is my mechanical advantage. So how do we solve mechanical advantage? Remember, mechanical advantage is what? Is load over what? Effort. Right, which is what? L over what? E over E, right? So from here, let's just impute what our values here. My load is what is 700 Newton. My effort is what is 200 what Newton. So let's get it here. So 700 divided by 200. Here we have 3.5. So you have 3.5. Is okay. So from here now, here we have 3.5. Here we have 3.5. So for me, my efficiency now is equal to what? My mechanical advantage is 3.5 over what? My velocity ratio is what? Is 5 times what? 100 over what? 1. This is that. So what do you have here? So here we have 3.5 times what? 100, right? Divided by what? 5. Here we have what? 70 what percent. So the answer is what? Is 70 what percent, which is what? C. It's okay. Now, if for example, here I have what 60 watt pulley. Now you know here I have what 7 pulley, and the load, let us say 850 Newton, right? And the effort is what 380 Newton, right? What is the efficiency of the machine? Now look at something here. I'm not with you. Now I'm only doing one part. And my own part is to show you how to solve this question. Your own part is to try as much as possible to solve this question using what I'm done, right? So I will advise you pause the video and solve this question and leave a word comment section, right? Like what I said, if you're enjoying this video here, please kindly give it a like and subscribe to the channel if you have not subscribed. Do you understand? I also share this video to other persons too, so that they too can be part of it. So if you have a group where they pay for JAMB, right? Kindly send this video, copy the link of this video and send to that group. Now tell you that this video will help them to work in their machine, right? This will help promote this YouTube channel too in such a way that what helping work in return as I'm helping work in return. Do you understand? But if you want to support my YouTube channel, you can donate any amount you want to donate. Do you understand? The account number will be at the description, will be on the screen. Send any amount and I will really appreciate it. So that I'll be motivated to produce more of this video. Remember, when you see a lot of people supporting your work, it shows that what you are doing is actually good. Do you understand? So now later what you are doing with the block and tackle system. This is how to solve block and tackle system is very easy. The next one is what the wheel and axle. Now you see it on the screen, right? You see the wheel, you see the axle. Now the wheel and axle is used to lift or to carry what a sand or water from a pit or from a hole. Just so here we have the wheel. The wheel is what you apply effort in the wheel, and the wheel have what a radius. We also have what your axle that bring out what the sand or water from pit is called the axle, right? Two of them have what radius. So let's look at the formula for the wheel and axle, right? Let's look at what the formula for the wheel and axle. So remember, what is velocity ratio? What is velocity ratio? Velocity ratio is what is distance moved by effort over what distance moved by load, right? So distance moved by what effort over what distance moved by what load, right? Now my effort is the wheel. This is the wheel, right there. So the effort, your effort is the wheel, right there. Just effort is the wheel, is the force you apply on the wheel here. Then my load is what is my axle. Just my is what is my axle here, right there. And each of them have their radius. So the radius what am I? Radius of what of wheel now is very big. That's what you use to apply it. So is what capital letter what arrow. Just the radius is what is capital letter. So the radius of a wheel is what is capital letter what arrow. Then the radius of axle is what small letter what arrow. So what you need to understand here is that this. We have to call the distance moved by effort, right? And effort is the wheel, right? Now remember, we are talking about circle, right? What is circumference of a circle? Now distance moved by effort is equal to what circumference of a circle, and circumference of a circle is what 2 pi r, right? So if you look at it very well, velocity ratio is equal to what distance moved by effort, because when you twist it here, when you rotate it here, is circumference. Just so which is what circumference of the wheel. Can say circumference of wheel over what circumference of the axle. Circumference. That will spell it very well. Of axle. Right there. Now remember, circumference. Now when we talk about circumference of a circle, is 2 pi r, right? Now remember, the radius of the wheel is what is capital letter arrow. The radius of axle is what small letter r. So here we can see that 2 pi r over 2 pi r here. Do you understand? So this is what you use. Please pay attention here. This is what you use. This is what you use in your calculation the velocity ratio of the wheel and an axle. 2 pi r capital the arrow over 2 pi r small letter arrow, right? So the big arrow is what is the wheel, the small arrow is what is the axle, right? This is what you use. Now remember, if you talk about efficiency. Now what is efficiency? Let me just explain some things to you here so you understand. So that by the time they choose this question, you should be able to know how to answer the question you want in the exam. Now, what is efficiency, right? Remember, efficiency is mechanical advantage about velocity ratio times 100/1, right? Another formula you need to pay close attention to is work output over work input. So here we have work output over work input. Right there. Now What does it mean? Remember, work output. Remember, work output is what is work done by the load. Work done by load, right? Over what? Work done by what? Effort. Are you here? So another thing you want to understand here is that the work output is what is load times distance by what? By load. Are you there? Over what? Effort times what? Distance by what? Effort. Are you there? So now we talk about the, now remember, the we is your effort you put in, right? While your ASO is the load, right? So here you can see that load times the distance moved by load is this one here. Distance moved by load is what? Is 2 pi what? Arrow over what? Effort times what? 2 pi what? Arrow here. Times, remember here we have times 100 over what? 1 times what? 100 over what? 1 is okay. So these are the what various formula you need when solving the we and ASO. When you are solving question under we and ASO when it comes to what? Machine. Now let's look at what this question here. With that, we should be able to solve this question with ease, right? So let's look at it very well. A we and ASO is used to raise a weight. Now here's the weight, right? The weight is the load you raise, right? So solution, so that is my load is equals to what? 720 newtons. Say a weight is used to raise a weight, which is a load of about 720 newtons with an effort. The effort you use to raise it is what? Is 200 what? Newton, right? So the effort you apply in the we to raise the is 200 newton. While the load it raise is what? Is the what? Is 720, right? Now, if the radii we and the ASO is what? 40 centimeter and what? 100 centimeter, right? Remember, we is what? Is the radius is what? Is going to be arrow here, right? Which is going to be what? 40 centimeter. And arrow here is what? Arrow is what? Is what? 10 centimeter, right? Remember that here we have big letter arrow, small letter arrow here, right? The big letter arrow is what? Is the what? Is the radius of the wheel. While the small letter arrow is what? Is the what? Radius of the ASO, right? So that's why we have something like this. But understand that we need to what? But understand that we need to convert centimeter to what? To meter. And when you're converting centimeter to meter, remember 1 meter equals to what? 100 what? Centimeter, right? So you have to divide this by what? By 100. If you divide it by 100, you have 0.4 meter. 0.1 what? Meter. Hope you understand. When they say you should calculate, they say, what is the efficiency of the machine? What is the efficiency of the machine? So which one are we going to make use of here? Right? Which one are we going to make use of here? You can make use of what? This formula. Load times 2 pi r over what? Yes, this is the formula we have to make use of. So I'm making use of what? This formula here, which we have derived. Efficiency is equal to what? The load, right? Load times what? This time by load, which what? 2 pi what? R over what? Effort E times what? 2 pi r times 100 over what? 1 is okay. That is it. So let's, you can say that 2 pi, you can say 2 pi here, right? Because they're the same. So what you have here? My efficiency is equal to what? My load. What is my load? 720 times my hour. Yes, small hour is what? 0.1. 0.1 over what? Effort is what? Effort is what? Is 200 times hour is what? Big letter hour is what? Is 0.4. 0.4 times so 100 over what? 1, right? So let's see. We have what? 720 times what? 0.1 times 100 divided by, here we have 200 times 0.4 For here we have 90. So my efficiency is what 90 what percent. That is what my efficiency. Do you understand? That is what my efficiency is. So you can see how you can solve question under what the we and what and also, right? So we are done what the question 3 and what question 4. Let's go to what question 5 and 6. Now let's look at what the question 5 and what question 6. And question 5 and question 6. Now the question 5 is what is screw jack, and the question 6 is what inclined plane or plane incline, right? So please pay attention here, because I really want to explain how to solve question under this one here. Now when it comes to what screw jack, remember efficiency, mechanical advantage, the formulas remain the same. The only difference between all the machines is their velocity ratio. So the velocity ratio of a screw jack is what V arrow is equal to what 2 pi arrow over what P, right? This is the radius, right? The radius is the length of the tummy bar. The radius is the length of the tummy bar. Why? This is what is the pitch. Do you understand? And two of them are what measured in meter. So if you look at the question here, you see that the angle of a screw jack of a pitch 4 millimeter makes you through a circle of radius 21 centimeter. So the radius is 21 centimeter. The pitch is 4 millimeter. Do you understand? 4 millimeter. Is okay. Now you must convert two of them to meter. To convert centimeter to meter, you divide by 100. To convert millimeter to meter, you divide by 1000. Just now. So when the question is being given to you in the exam, you have to convert any of the unit to meter. So at times the meter will be given to you straight, but at times not be given to you like this one here. They gave centimeter, they gave millimeter, right? The radius is 21 centimeter. How do you convert centimeter to meter? By divide by 100. If you divide this by 100, here we have 0.21 millimeter. Do you understand? 0.21 meter, right? So what about millimeter? 4 divided. Here we have if you convert millimeter to meter, here you go to 0.004 meter. Do you understand? So once they say you will calculate the velocity ratio of the screw jack, as easy as that. So you just increase the value here. Pi is 22 over 7, right? So velocity ratio is equal to 2 times 22 over 7 times what? My arrow is 0.21 over pitch is 0.00 4. That is it. Remember, here is meter, and here is meter. Meter what to go at. Hope you understand. So now let us solve it here. 2 times 22 divided by 7 times 0.21 divided by 0.004. Here we have 330. 330. So here we have 330, right? So my velocity, the velocity ratio is 330. The answer is D. Just the answer is D. As easy as that. So the next one is going to be what? My plane incline or inclined plane. Very important here. So let's look at what the inclined plane of the machine. Now let's look at what the inclined plane here. These are an inclined plane at an angle of 30 degrees to the horizontal has an efficiency of 50%. The force parallel to the plane required to push a load of 120 Newton uniformly up the plane is. So they're asking you here, what is the effort you need to push the load of what? Of 120, right? Look at them here. Yeah, it's very easy. Just pay close attention here. Remember, the efficiency of the machine is because what? Mechanical advantage over what? Velocity ratio times 100 over 1 is okay. Now, yeah, if you check it very well, they give you efficiency. My efficiency is 50%, right? Now, Then wait for that to give what the load. My load is what? What is my load? 120 Newton, right? Now they're asking of the effort to push what the incline what plane. Just I'm going to be able to get the effort is very easy. We are going to use the mechanical advantage is equal to what load over what effort, right? Once you make effort the sort of formula here, therefore you have my effort equals to what load over what mechanical what advantage, right? So if you check it very well, once I can calculate what my mechanical advantage here, right? I can really what get what my effort I use in pushing what the load in the what along the what incline plane. Now let's look at what the incline plane so I can get what velocity what ratio. Right? Remember I told you that each type of machine have their own different way of what calculating what their velocity what ratio. Like we have looked at what the screw jack, we have looked at what the wheel and axle, and we have looked at what the other ones are forgotten, right? So now incline plane is under what type of machine you need to understand what the how to calculate what the velocity what ratio. So now let me explain to you. Very easy. Now you look at what incline plane here. What is the work of the incline plane? The work of an incline plane is to help us to push an heavy load to a truck or to an height, right? So you can place a plank or a wood, right, to a certain height. Then what happen here? You cannot easily push the load with a little effort, right? Or like when you want to just carry the load from that height, like that, it's not going to work, right? So that what we call what incline plane. So this is the height of the plane. This is the distance. So this is the load. You impute what effort here. So this is the height. So the height is what is the distance of load move. Distance of load. Distance move by what load, which is what is L. Distance moved by load. Then from here it's going to be what distance moved by effort. Distance, which is length here, my L here. Distance move by what effort. I get distance what moved by what by effort. So now remember when an inclined plane is what. When an inclined plane is with what is inclined with what with the horizontal here, there's an angle here. Just and there's an angle, right? So now there are two formulas for velocity ratio when it comes to what inclined plane. The first one, remember, what is velocity ratio? What is velocity ratio? Velocity ratio is what is distance move by what effort over what distance move by what by load. Just that. So the distance moved by effort is L. That is the length of the inclined plane. The length of the inclined plane, right? Then like the length of this one here, the length. Why distance moved by load is the height. So you can use one here. So distance moved by effort is this one here. Why the height is what is the effort. So this one is one formula here. Another formula you need to understand here is that velocity ratio equals what sine theta. How do you come about sine theta, right? How do you come about sine theta here? It's very easy. Remember in trigonometry, that is why if you really want to pass very well, you need to know the three identities. Special angles, angle 30, angle 60, and angle what 45. You need to understand those things very well because you're going to see in the exam. Now, look at something here. Socatua. Right? Now, if you look at it very well, my height is my opposite. My distance, my length is what is my hypotenuse. Just so my sine theta here is going to go opposite, which is what is my height over what I just said, which is what my L. Just so we use this one here. So velocity ratio is always the same as sine theta. Velocity ratio is what to L over what H, always the same as sine theta. So if you look at it very well, this is the what to get my velocity ratio here. You are not, because here they gave us the angle here. If you check it there, they give us angle. What is the angle here? They give us angle what 30 degree. Angle what 30 what degree. So yeah, the mission here is to just get what my velocity what ratio. Get what my velocity what ratio. Get what my velocity what ratio. For my velocity ratio equals what sine what 30 degree, right? And in the three identities here, in the what spatial angles here, in the spatial angle, like here we have spatial what angle here, right? Here we have 60, here we have what 60, here we have what 30, here we have what 30, here we have 2, 2, 1, 1, right? So if you should draw it out like this, 60, 30, 2, 1, square root of 3. Now you need to understand this very well. I don't know. Go and check my video on what trigonometry, or you see a picture that explains all the spatial angles, right? So you don't need to cram it, but you need to understand the angle 60, angle 45, and angle 50, and angle what 30. There, what is sine theta, cos theta, what is cos 45, sine 45, and what's tan 45. You need to know those things very, because you may not have time to know these things here. So there will be a picture, right? You just have to screenshot it and keep it and start using it. Now you talk about sine theta, right? Remember, you have opposite over what hypotenuse here. My sine theta is, my sine 30 is what is opposite over what hypotenuse, which is what 1 about 2. If you don't know how I got this one here, go and check my video on trigonometry. For you to get the video on trigonometry, just leave a message that you want the video on what trigonometry, and I will send you the link directly so you can understand it better. But I don't want to go into this one here. Now we know that sine 30 degree equals 1 over 2, which also takes as what 0.5, right? So since we know that our V what arrow here, velocity ratio is 0.5, what happened here? Let's repeat our values here. So mechanical efficiency equals what? My mechanical what advantage over what? Mechanical advantage over what? Velocity ratio times 100 over what? 1. So now let's make this guy subject to formula here, because the goal is to what? Get what? My mechanical advantage. From there, I can really apply to get what? My efforts, because they say what is the distance, like what is the force used to push what load, right? So if you make mechanical advantage subject to formula here, what are you going to get? Mechanical advantage is equals to what? Efficiency times what? Velocity ratio over what? 100, right? So what you have here? What is my or what my efficiency? My efficiency what is 50. So we have what? 50 times VR. What is my VR here? 0.5 over what? 100. So here we have 50 times 0.5 divided by what? 100. 0.25. 0.25. 0.25. 0.25. I there. 0.25. So my mechanical advantage that equals to 0.25. Do you understand? So now let me just solve the remaining stuff here, right? So remember, they're asking to calculate my effort here, right? So E is equals to, now what is my load? My load is what? 120 newton over what? My mechanical advantage is what? 0.5. 0.25, right? So you have 120 divided by 0.25, give you have what? 480. So my effort equals to what? 480 newton. That is the what answer. All this video is effort. If this video is effort, please give it a like and subscribe to the channel if you're not done that. Now, the next type of question is going to be what? Temperature. Temperature is not going to give us educates. Temperature is what is straight the point. So let's look at what temperature. Let's turn our attention to what? Temperature, right? And I'm just going to solve these two questions on temperature, because temperature is not that too wide like that, so it's just straight to the point. right? Or like machine. Now, when we talk about temperature, now temperature is used to measure the hotness or coldness of a body, right? And temperature have three different scale. Now, here we have the Kelvin scale, the Celsius scale, and the Fahrenheit scale, right? So these are what the three main type of scale in what when it comes to when measuring what the temperature of a body of a substance. Now, each of these scale have upper fixed points and lower fixed points. Right there, we have to call the upper fixed point. Let me know why, please. Here. Upper fixed points. And here we have what lower fixed points. Here we have lower fixed points. Right there. Now, the upper fixed point is also about the steam points, while the lower fixed point is not about the ice points. In between the upper fixed point, we have what called the fundamental interval. Fundamental interval. Here we have fundamental what interval. Right there, we have what we call fundamental what interval. So the upper fixed point and what lower fixed point. So each of these scale have upper fixed point and what lower what fixed point. That's what you need to know here. Upper fixed point is also known as what steam point. Lower fixed point is also known as what ice point. So the look at what the upper fixed point of Kelvin scale and lower fixed point of Kelvin scale. Look at it for degree centigrade and what for degree centigrade and what Fahrenheit scale, right? So what is the upper fixed point, or what is the upper fixed point? What is the upper fixed point for Kelvin? The upper fixed point of Kelvin is called the ice point here. Here you can just do it like this. Right there, can just do it like this. Right there. So the upper fixed point of Kelvin here is what 373. Or you can just do it like this. 373 what Kelvin is okay. So the upper fixed point of Kelvin scale is what 37 Kelvin. 373 what Kelvin. While the lower fixed point is what 273. 27, right? Yes, Kelvin. It's okay. That is it. So the upper fixed point of Kelvin scale is what 373. While the lower fixed point of Kelvin scale is what 273, right? Now for degree centigrade here, the upper fixed point is what is 100 degree what centigrade, while the lower fixed point is what 0 degree what centigrade. Now for the Fahrenheit scale, the upper fixed point or the ice point is what 212 degree what Fahrenheit, while the lower fixed point is what 32 degree what Fahrenheit. Do you understand? So these are things you need to place or put your mind when you're solving any question under what temperature. And remember, each of them can have what their interval. Just so I'm going to show you how to solve different questions. So let's get into each of these questions here. But understand here. So let's solve these two questions. So look at something here. See that a temperature scale has a lower fixed point of 40 millimeter and upper fixed point of 200 millimeter, right? So we don't know the scale they are using here, but they say that a temperature has what a lower fixed point here. Remember that here we have what lower fixed point here. This is what, let us say this is what lower fixed point here. Let us put on here as what as 40 millimeter, right? While the upper fixed point is what is 200 what millimeter, right? So let's say what is the reading on this scale when a temperature reads 60 degrees centigrade here. Now they gave us what one of what the scale in temperature. Remember, temperature can be measured in what Kelvin scale, Celsius scale, or Fahrenheit scale. Now they gave us what for what Celsius scale, right? Which is this one here. Remember, in Celsius scale, we have what called the upper fixed point and lower fixed point. So the upper fixed point of Celsius scale is 100 degrees centigrade, while for the lower fixed point is what is 0 degree what centigrade. Now they are asking you here, look at what they're asking you. They're asking you what is the reading of this temperature when the degree centigrade is reading what is reading. Let's just say is reading what 60 degrees centigrade here. So here we have what x as well as this. So how do you solve this here? So they're asking what will this guy read when the reading for what the degree centigrade is 60. So here you are going to look for what x. So how do you solve this here? Please pay class here. Every question under what temperature scale, under temperature question down like this. They will give you what one type of what scale, and they will compare what with another scale, right? So just like the way this question look like. So let's solve it here. To solve this here is very easy. The upper minus, so look at something here. Let us say here we have the upper minus what this thing, this minus this. So this I go to just watch. It's very easy. So let it be what 200 millimeter minus here out 40 millimeter over this one here x minus what 40 millimeter. Do you see that? As easy as that, equals to the same thing here 100 degrees centigrade minus what minus 0 degree what centigrade over 60 degrees centigrade minus what 0 degrees centigrade. Do you understand? You can see how easy it is. So 200 minus 40, 200 minus 40, here we have what 160. So here we have 160 what millimeter over x minus what 40 millimeter, right? It's okay. So here we have 600 minus 0 is what is 100 degrees centigrade over what here we have what 60 degrees centigrade here, right? Centigrade we cancel out this one here. You can see that. So what do we have left? Let me write this place out. Let me write this place out. So here we have 160 millimeter over what x minus what 40, right? So here we have 100 divided by 60. Here we have 1.67, 1.66 right? Now let's ignore the millimeter here, so that you don't confuse us here. But understand that this is what is the millimeter, right? So we should cross multiply like this. So up here 160 equals to what 1.667. Here we have x minus what 40. This is that. So we have what 160 equals to what? Once open the bracket, you will have 1.667 what x minus. You have 1.667 times what 40. You will have 66.6 what 8. This is that, right? So now let's make this guy the subject of formula. So if you should make this guy the subject of formula here, the x the subject of formula. What do you have here? Like the other to move here, you have what 160 plus 66.68 equals to 1.667 what x, right? So when added together here, 160 plus 66.68, you have what 22.668 equals to 1.667 what x, right? Divide both sides by x, making a solid formula. Here you have what 226.68 over what 1.667, right? So divide by 1.667. Here we have what 135 equals to what 135 what 136 millimeter what mercury. So millimeter. So the temperature is what is 136. 136. Yes, we have the answer here. 136 millimeter. That is what answer. Now I'm going to leave this one with you. What is the equivalent of temperature of 20 degrees centigrade in Fahrenheit? Go ahead and solve this one. I'm a little bit tired here. You understand? At least I've tried. So go ahead and solve this kind of question here. Now, every question under temperature follow this pattern. Just follow exactly what I've done. They try to see how I can solve problem on that. Right? Here they are relating two temperature here. The Fahrenheit scale, the degree centigrade and Fahrenheit scale. Just and I'm giving you that. So use the method I've done and I'll solve question on that. right? If this video is helpful, please like, comment, share that this video is helpful. If you want to support my YouTube channel, you can support, right? Any amount will go a long way to say that, okay, I value what you are doing, use this for data, right? Because the cost of data is is high, right? And I upload like 2 times a week, just and it's very costly on a more serious note. Without data, there's no way I can be online taking you guys. Most of my videos are extremely designed for you guys who write JAMB. So if you want to support this channel here, send any amount you want to use, and I will appreciate that. In my last video, a lot of places have started supporting, and I really appreciate that. But more can be done, right? Thanks for watching. If you have not watched the last video, please kindly check out the last video on this JAMB Physics revision class. It's going to be of great help to you. Thanks for watching. See you in my next video.